Hi everyone, welcome back to our YouTube channel, Becoming a ROS Developer. I am Desire, and today we've got Wen. She's just completed the course ROS 2 Navigation, so she will be giving us a presentation on that. And what we'll see is a demo on the real robot, is as always, and then we'll get into the details about her project after that. And then towards the end, we'll get to ask you a couple of questions to get to understand exactly what she did and how she did it. I'll now hand over this platform to her so that she can begin her presentation. All right, whenever you're ready, Wen.
Oh yes, I'm ready. Thanks for the introduction. And now I want to present my roster navigation demo. Now I have launched the plan, the location and the planning, and this is the aviary, and I'll give it go post say the navigation for me. Yes, it can reach the goal. Try it again.
All right, so you started by showing how it moves from corner 1 to corner 2. Is that right?
Yes, and I record the corner 1, 2, 3 position in my YAML file, and
Okay.
now I'll try to use the
Okay, I see.
yeah
I see. So you're still recording the poses that you
yes
wanted to get to. Okay.
yes now it will go to the corner 1. Planning is good. Race yeah success, and then the corner 2. Yeah, and then corner 2. And I got another position in the middle of 3 at the yeah this. Now I want to let the robot to move to the corner 1. It will across the middle, I think.
Okay.
It's too close to the obstacle. I will see, recover from. Yeah.
All right.
Now it don't have a valid tragedy, and it will move on. Yeah, success.
All right. So we see that you're already using a map that an already existing map, right?
Yes.
Can you at least do a slight demo of how you managed to build the map, or
Oh
how
yeah.
you did it? Yes.
Okay. The build the map process. Right?
Mm-hmm.
Okay. I will. I'll check the package. The map.
Okay. Can you be explaining what you're trying to do?
I need to change that. It's the cartographer.
Uh huh.
Yeah,
Okay.
I need to launch the uh to note the cartographer in the cartographer roles package,
Uh huh.
and then to note the cartographer and the cartographer grid nodes.
Uh huh. Okay.
Now it's yes, the grid node will pop the map, and now I will do the number. Oh, I think I can do this. Yeah,
Okay.
and then move around in the environment.
Okay. All right. I see.
Yeah, move to every corner,
Uh huh.
and it will and then sorry, and then call the map server client, the service client, and save the map.
Okay. All right. All right. I see. I see. Okay. Very well done. You can also continue explaining your code. I just wanted to see that bit since you didn't show us how you built the map.
Okay. The map build code, right?
Yes, the map build or
Yes.
any other code section that you wanted to explain. Uh, that was my
Okay.
way of highlighting that I wanted you to demonstrate how to build the map first before you went to using the YAML file to pass the pose that you want the robot to go to.
Oh yeah. And this is the mapping used to map. This is the node, and I need to launch this two nodes.
Mm-hmm.
And this one is has the config file. Is the yes, this config file
Mm-hmm.
configure, and this is the grid node. It will publish the map, and then we need to use a command to save the map. I think it is the map server client CLI, and give the maps file's name
Mm-hmm.
as the parameter, and it will save to the uh, you the file you define.
Okay. All right.
And then if I have the map, I need to use this map. I need when in the localization, and I need to launch the map server also, because it will publish the map I have
Okay.
built. Yeah.
Okay. Okay.
And I will use the MCL algorithm to localization. It will have I have the slice. I just use the slice.
Yeah, you can. You can.
Yeah. Okay.
I was stuck on that. I wanted to understand, okay, what do you use the AMC or not to do, right? So if you can use the slides to
Yeah.
explain that, yeah, let's go on.
Okay. The MCL it will I will use the MCL algorithm to do the localization, and the MCL will give the transfer between the map and the DOM, because in the mapping progress, and we have built this TF tree, and then the MSL will give the map transfer between the map and a DOM, and the DOM will link to the this link, and then the robot will know the books.
Okay.
So
Okay.
it is the localization, yes, and we will have the MSL post topic that we can use it later.
Okay, can you explain to me a little bit which part of the of the tree will the sampling points be sampling, right? Which part of that TF tree will the AMCO particles be sampling?
These two parts, the AMC will give the map to adopt.
Mm-hmm. Okay. Yeah, but in
Yeah.
the process of localizing, right? Which part is being sampled? Which part of the tree is being is the point that is being sampled by the particles?
We need to give the initial pose. If we don't need give the initial pose, it will put the particles randomly in the map.
Okay,
And
all right.
if we give the initial pose, yes, it will convergence fast. Yeah.
Okay, so it basically it is the odom that will converge to a certain point, right? And then it will relate the AMCO will be responsible for relating that to the map, right? So that it knows
Uh,
relative to the map where is odom, right? Or where is the best
yeah.
link to say that, yeah.
Yeah.
All right. So let's go on.
Yeah, and this is the path planning. We need to this two this called this two this is four nodes, and the we need to in the path planning we will use the planner server. It is used to the global planning and for the planning to the path from A to B and according to the given cost map. Because we build a map, it will be a cost map, global cost map, and it will give global planning. And the controller server is more like local planning. It will detect the obstacle around the robots and give a local planner to escape the obstacle. And if no legal trajectory, if it have detect to collide to the obstacle, it will keep do not move. And
Okay.
if it just don't get the trajectory and didn't collide, it will move around and find the trajectory.
Okay, can you, while we're on
Yeah.
that point, can you give me the three default behaviors that it should try before it just chooses to stop or quit?
Stop. We
What are the
can you?
three default behaviors, right? That our
Oh yeah. And the behavior server it will handle the high level navigation decision use the behavioral tree.
I mean the behaviors when when your robot encounters an obstacle, right? What are the
Yeah.
three default behaviors that it should try first before it?
No, it will stay there, do not move, and
Okay.
I can recovery from that. I can move it and let the robot know it's far away from the obstacle. Move it far away from the obstacle, and it will recovery. And
Okay.
yeah,
Okay. What I was looking for is the first three that it should try is the rotate in place, right? Rotate in place, move backwards, and then maybe stop, right? Or
yeah,
yeah. So I wanted you to specify those, but it's fine. Let's go on.
yeah. And this is the navigation post. I need to get the posts. The planner server we, we will the post record pack in the post record package. I write to it has service in this package and the name is the record post, and this node will subscribe the MCL post and download the chosen post when I call the service, and it will download in a YAML file, and it had its format, and then I need to I make a action client for the action navigation tool pose. I think it's the name, and it will read the point location from the spot list YAML file and move the robots to the desired spot, and record the position. When it reached, it will print the success.
All right. How else could you pass a goalpost, right? Besides using RVs, how else can you do it? Besides using RVs and using YAML file.
It will the test planning is the same. It's the
I think you didn't get my question. My question was, you can pass a goalpost, right, using RVs, or you can pass it using the YAML file, right? What is the third way you can do it? Which other way can you pass a goalpost to your robot?
How can I use the YAML file to go to the target post, right?
Or any other post. How can you pass it to your robot? There should be 3. You probably did it, but
because I call the action server the navigation and navigate to post. That's action server.
Okay.
And give the request. Yes.
If you're referring to passing it in the command line, that's what I wanted to say, right? So if you say you pass the goal to the server in the command line, that is the way that I was looking for. Is the third way.
I write a note to do that.
Yes, you can also do that, but it's all right. Let's go on.
Yeah, that's all.
all right. That's fine. A couple of questions though. I would want to ask you how else could you, let's say, how else could you localize your robot, right? Besides using RVs, how else could you localize your robot?
In the RVs?
No. Let's say you're not using RVs, right? Is there any other way of localizing it? If there is, how do you do it?
If I want to localize the robot in the RVs, I don't do that. The RVs just show the base, right?
Yeah, all right. Yeah, well, the other way would be if you know the exact coordinates, then you can pass it in a file as ROS params, right? To say, okay, my robot is on this coordinate, then you to localize using that coordinates. But you would have to know the exact coordinates on which the robot is, right?
Yeah. When I move to the first corner, it's determined by me, and I know the robot is in the first corner, and then I call the server, call the service, and record the current AMCL position.
Yeah, that
because I subscribe the AMCL poll.
Yes, it's another way of doing it. It's like you are recording the coordinates of where the robot is using that that script that will record the coordinates of the robot when you drop the pin in RFS. It's almost like doing the same thing, but it's like giving you a GUI to do that. Whereas the way that I was speaking about is more abstract because it's just saying, assuming you do know where that place is, right? So, yeah, but yeah, the principle is the same.
Okay.
Yeah. Let me see if I have any more questions. What would be the effect of increasing the number of particles that the MCO uses, right, in the localization?
Increase the particle.
Increasing the number of particles that the MCO uses. What would be the effect of doing that?
If I increase the number of particle, what's the result? Or
what changes would it make to your whole
Oh,
navigation?
we can change the configure file, I think.
No, well, not really. Not really. I was actually looking to understand if there is any effect that the particles will bring to your localization pipeline, maybe to the map, to the localization process. What changes does it bring if you increase those particles?
It will lower the conversion speed, I think, and it
That's
will
true. Yeah.
and oh no because if we have more particle number, it will spread its the range and to get more pulse and orientation, and
Mm-hmm.
then I think it's more accurate.
Yes, well, that's what I wanted.
Yes,
Yes, so it will make your localization more accurate, right? Because you've got more
yes,
sampling points, right? So
yes.
it will
But the
also,
speed,
it does do
I
cost, it does put a
yeah,
cost on your hardware, right? So it will localize more accurately, but it might take time, right? That's also the rate of conversions might be slightly
yes.
slower, like you said earlier on. So yeah, but yeah, well done on that. um I think that's it from my end. So we'll wrap it up here and then we'll finish our conversation on Zoom, all right?
Okay.
All right. All right, everyone. So this was Wen's presentation. We highly encourage all those of you who would like to take on the courses we offer certification on to come and do that. As this will enhance your learning procedure, it will also make you better at explaining the things you've been doing to someone else. So until next